Hello students, in this video let us learn about coherent sources. Coherence is an important term that we come across when we study about interference of light waves. By coherent sources we mean two sources producing coherent waves. And two sources are said to be coherent when the waves emitted from them have the same frequency nu or same wavelength lambda. So both are correlated. If they have same frequency, they will have the same wavelength, and they should have the same or a constant phase difference. And let us see two waves that are coherent. So these are two waves produced from two different sources, S1 and S2. So as you can see, the first wave is like this. The second wave has the same wavelength lambda. So the crest and crest will come together and the trough and trough will align together. And they have the same phase too. Here the phase difference is 0 because we can see that the crest and crest is aligned and the trough and trough is aligned. That means they do not have a phase difference. So either they can have no phase difference at all, or they can have a constant phase difference. For coherence. So I will show you one wave like that. So in the case of constant phase difference, one wave can go like this, and the second wave will have the same wavelength, but it will be slightly displaced like this. Here crest and crest is not aligned together, its crest is here, the crest of the first wave is here and that of the second wave is here, and again the next crest comes here. For the second wave, crest is here. Since they have the same wavelength, this phase difference is being repeated. This phase difference is being a constant. So two sources are said to be coherent when they have the same wavelength and they have a constant phase difference. In order to observe the phenomenon of interference, we need to have coherent sources. Related to this coherent sources, we can also define some other terms like coherence time and coherence length. Coherence time is the average time during which the wave remains sinusoidal and the phase of the wave packet can be predicted reliably. So as we know, as wave propagates to further distance, its properties may change because it might get damped and so on. So its phase will shift and many other small perturbations can happen to this wave. So coherence time is the time up to which this wave could remain sinusoidal and its phase can be predicted. Then we can also define coherence length as the length up to which a wave packet may be assumed to be sinusoidal and of predictable phase. So coherence time and length are correlated up to what length this wave is going as it is predicted, and after that may get damped. Similarly, coherence time is this time from here up to here, the time up to which this wave is remaining sinusoidal and of with a predictable phase. In the phenomenon of interference, it is important to have coherent sources, and normally a technique that we use to produce coherent source is like this. We will use a single light source, and using a single slit we will form a narrow beam of light. So we have the single source S1 here, the first slit from which we are having a single beam, and as this wave spread out we place two further slits here, say S1 and S2. Suppose this is S, and these two slits splits this wavefront into two. So we have small two other sources here. These are actually produced from the same wave itself. So these two sources S1 and S2 can actually act like coherent sources. When we use two different light sources, suppose we have one bulb here and a second bulb here, these two bulbs or the light sources need not produce light waves of same wavelength or same frequency and constant phase difference, because they are two different light sources, right? They can have different properties. It's very difficult to get coherent waves from two different light sources. So in order to produce coherent light sources, coherent lights, we use a single light source from which we produce light wave of same frequency or same wavelength, and then we split this wavefront into two, which can act like two coherent light sources. So here we have two waves coming from the two sources. They will have the same wavelength and frequency and constant phase difference. So this is how coherent source is achieved in interference phenomena, as we will see later in the experiment of Young's double slit experiment using two sources. This is how coherent sources are being produced. So this is about the idea of coherent source. I hope this portion is clear for you. Thank you.